So this is CPM Precalculus, Chapter 1, number 39. Okay, so this is a problem where we have right triangles again. And we have to use the idea of an inverse to find the missing angles in each triangle. Okay, so for A, we have a right triangle. Right, here's the right triangle. We have an angle X. We have a hypotenuse of 12 and another side of 7. We don't know this side. We don't know this angle, right? So question mark there, question mark there. Okay, so first of all, it's saying use the idea of an inverse. Well, first of all, we know SOHCAHTOA, right? SOHCAHTOA. Now, again, if we know SOHCAHTOA, if using X as a reference, which one should we use that will include both 7 and 12 and not this question mark? So we can think of sine is opposite over hypotenuse. Opposite is 7. Hypotenuse is opposite the right angle, which is 12. So sine it is. So sine with the input of x, so sine of x is equal to opposite, which is 7, divided by hypotenuse, which is 12. Okay? So how do we solve for x? Well, the idea of the inverse is we want to undo the sine function. We want to undo it. How do we undo the sine function? Well, we know if we have f of x, the opposite or the inverse, right now we call it inverse, is f minus 1 of x. Okay, so this is the inverse. So sine is actually, if we want to do the opposite, how do we undo sine? Well, let's see if we could do the inverse of the left. And so if we do anything to one side of the equation, we have to do it to both sides of the equation, right? So sine inverse of 7 over 12. Okay? So inverse and sine cancel out. So we just left with x on the left is equal to sine, well, the inverse sine of 7 over 12. But what's that? If you look in your calculator, above sine, you're going to see in yellow the inverse sine. Second yellow sine, so sine to the negative 1, which is the inverse sine of 7 over 12, is equal to 35.68533471. So we could just approximate it because I'm not writing everything, and this is going to be degrees. If my calculator was in radians, what am I going to get? So let me just make sure my calculator mode is in radians. I do the same thing and I get, or x is equal to 0.6228. So that 8 makes this next 2 go up to a 3. Approximately 0.623 radians. So radians, I could shorthand just say rad. Okay? So x is equal to one of these, in degrees and in radians. Okay, for part B. Part B is similar. We have another right triangle. Oops. It's upside down. There's the right angle. This is y here. This hypotenuse, again, is opposite the right angle, so it's 15. This side is 5. This side up here is unknown. We want to find the missing angle. Well, we know sine is of this angle would be opposite, which is the question mark over hypotenuse, so let's not use sine. Tan is opposite over adjacent. We do not want to use the opposite. So we're left with cosine, ka. So ka. So SOHCAHTOA, so it's the ka. So cosine of our angle, which is y, is equal to adjacent, which is 5. If you ever forget, remember, opposite the right angle is the hypotenuse, which is 15. So even though these are both next to y, this one's reserved for the hypotenuse. Okay, and again we want to do the opposite of the cosine, so to undo it we want to do like the inverse cosine. So if we want to do that, we have to do it to both sides of the equation, right? So we can, I'm going to use a different color. So cosine, inverse cosine of cosine y is equal to inverse cosine of 5 over 15. Okay, inverse cosine and cosine cancel each other out, so we're left with y only is equal to the inverse cosine of 5 over 15. So again, in our calculator, we have that functionality. It's right above cosine in our TI-83. If you have a different calculator, it's there too. I mean a graphing calculator at least. And depending on your mode, you're gonna have two possible answers. So if I am in degrees mode, I can say y is approximately 70.52877. So I'm going to round the 8 to a 9 because it's followed by 7 degrees. Or if I put it in radians in my calculator and plug it in, I get 1.2309. So the next 0 I'm going to round up because that 9 next to it makes the 0 round up. And this is radians. So I can have either one of these answers for part B. Okay? So this is using the idea of an inverse. See how we use the inverse of cosine, the inverse of sine up here, to find the missing angle of the triangle. And that ends CPM Precalculus Chapter 1, number 39.